Hey YouTube, it's the Test Lead, and today's video is the solid software design principles to help you write better code in object-oriented programming. SOLID is an acronym to help you write clean and reusable code. The acronym stands for the following principles. S stands for single responsibility, O stands for open close, L stands for Lipscomb substitution, I stands for interface segregation, and D stands for dependency inversion. This video will give you a high-level introduction into each principle and also why each principle is important for clean and reusable code. Don't forget the main goal in object-oriented program is to write clean, reusable code. So first, the single responsibility principle. The single responsibility principle is based on the concept of a class should only have one reason to change. A class should only have one responsibility. And you should also be able to define what a class is doing in one line. The purpose for this is having a class that only has one responsibility allows for easier usability. If a class is doing several different things, it makes it harder to use that class efficiently. You then may try to extend a class that does multiple things, and then the child class may not use all of its functionality, which is not proper practice when extending classes. We'll talk more about inheriting from classes in later principles. But remember, single use should only have one reason to change. Next, the open-close principle. The open-close principle is a concept that stands for open for extension, but closed for modification. So first, focus on a strong base class. Anything that wants to use the functionality from that base class, as well as add to it, will inherit from that base class. So here's the open to extension. You have a good base class and you want to add extra functionality, you're going to extend it, which is perfectly fine for object-oriented programming. However, the user should never try to modify the base class. This is a closed modification concept. The user should never modify the base class itself. Just think, if we have a good base class and we have 10 classes extending that base class, if I make a change to that base class, 10 classes are going to be affected by that. And if we give anybody the ability to modify that base class, one person that's extending from it might try to modify it for just their unique purpose, but now that destroys the usability in other classes. Also, when we continually add to base classes, we will run into conflict sometimes with the single use responsibility, because we want to add one extra use to this base class, and if 10 people do it, now you have 10 uses for this one class, which becomes overwhelming and makes it hard to actually reuse properly. Next is the Lipscomb substitution principle. The Lipscomb substitution principle is based on the concept of subtypes should be substitutable for their base types. This concept was made because people try to inherit from base classes that they have no business inheriting from, because they just want to use some of the functionality from the base class to save a few lines of code. That's not proper inheritance. Any subclass should be able to substitute the parent class in all instances and the code still works. If a substitution cannot be performed properly, then inheritance should not be used in this instance. Instead, you should create a brand new subclass with the functionality that you actually need and then inherit from that. Interface segregation principle. The interface segregation principle is based on the concept that dependencies on classes should depend on the smallest interface possible. It is better to have too many interfaces than too little interfaces. Instead of having one giant fat interface that relies on a lot of different classes, it's better to break up and have several smaller interfaces. You can also split the responsibility of a class without violating the Lipscomb substitution principle. So the main thing with interface segregation is anyone who is using the interface should not be forced to implement interfaces that they don't use. This would force them to create a dummy implementation just to keep the compiler from complaining. The smaller interfaces should be based on groups of methods where each one serves as a submodule. If you don't have an interface, you're just using one part of it and the rest just has dummy data. That defeats the whole purpose of having an interface. So remember, small, lean interfaces. That way it will be properly used in the code. And last but not least, dependency inversion principle. The dependency inversion principle is a concept that you should depend on abstract and generic interfaces instead of concrete classes. This mainly applies to inheritance. Many concrete classes are made for just one specific use and are not made to be reusable. Because of this, when you're trying to inherit from a concrete class, you often have to keep changing it for your particular instance. So instead of having a concrete class, have generic classes with generic variables. That way there's more instances when it can be reused because it's generic. Because if you try to keep changing one base class, this violates our second principle, the open-close principle, where the base class should be closed to modification. It also becomes tedious to always update a class. Instead, use an abstract class or interface. An abstract class is purposely just used as a template for other classes to inherit from. It often contains generics so that it can be more versatile when reused. So don't forget to try to have abstract classes or generic interfaces and then inherit from those. And that's it. That wraps up the solid principles of object-oriented programming. If you found this video helpful at all, please like, share, and subscribe. If you want a video just like this, please click here. If you want to see my most recent video, please click here. And hey, don't forget to learn something new today.